There are three main properties of logarithms. The first one is the addition property, which states that when you add logarithms together that have the same base, so for example, log base b of x plus log base b of y, then you can multiply the arguments and write it as a single log, so log base b of x times y. The subtraction property states that if you subtract two logarithms that have the same base, so log base b of x minus log base b of y, then you can write the logarithms as a single logarithm and divide the two arguments, so log base b of x divided by y. And the last property is the power property, which if you have a number in front of a logarithm, so a times log base b of x, then you can write that number a as a power inside the logarithm. So log base b of x to the power a. So the number that's multiplied in front is moved to become a power. Example 1, write the following as a single logarithm. 5 log x minus 3 log y. Now the base of both of these logarithms is 10, so we can use the properties to combine them. But we'll always use the power property first when we're combining logarithms. So the 5 in front of the logarithm with x is moved to the exponent, and the 3 in front of the logarithm of y is moved to the exponent of y, to give log of x to the 5th minus log of y to the 3rd. And now to combine these two logarithms, we can use the subtraction property, which states that when we subtract two logarithms that have the same base, we can write them as division with a single logarithm. So we can turn this into log of x to the 5th over y to the 3rd. Example 2, write the expression as the sum or difference of logarithms with all variables to the first degree. So for this example, we're going to split up this logarithm into different logarithms using the properties of logarithms, but using them in the reverse order to which we used in example 1. So within this logarithm, this is ln, which means log base e. We have division within the logarithm, so we can split up the logarithm using subtraction. So we can write this as log base e, or ln, of a to the 3rd minus ln of b. Because of the division, we can replace this as separate logarithms with subtraction. And now we can use the power property on the ln of a to the 3rd and move the power 3 to the front of the logarithm. So that would be 3 ln of a minus ln of b. And now this is written as a sum or difference of logarithms with all variables to the first degree. Example 3, write the expression as sum or difference of logarithms with all variables to the first degree. So same process. This time we have x squared and then the 5th root of y within the logarithm. So really there's multiplication between those two pieces. So to split this up, we would use the addition rule, which states that the addition of two logarithms means to multiply the arguments inside. So splitting this up, we would get log of x squared plus log of 5th root of y. And now we think about how to write 5th root of y with an exponent. So whenever we have a root, let's say we have the rth root of some variable, that is x to the 1 over r, written as an exponent. So 5th root of y we could write as y to the 1/5. So let's then write this as log of x squared plus log of y to the 1/5. And now we can use the power property with both of these pieces and move the powers to the front of their respective logarithms. That would be 2 log of x plus 1/5 log of y. And now this is written as summary difference of separate logarithms with each variable to the first degree.